Welcome back to ie537, Large-Scale Systems. We're going to continue today talking about decision theory, decision analysis. We're going to get into very closely related areas of utility theory and game theory. First, utility theory. There's this underlying notion of a lottery that becomes valuable for us to understand just what a lottery is. First of all, definitions. A lottery is a contest in which tokens are distributed or sold. The winning token are tokens being secretly predetermined or ultimately selected by random drawing. I'm sure many of you have heard about and maybe even engaged in the Powerball. It's similar to that. A selection is made by lot from a number of applicants or competitors, and an activity or event regarded as having an outcome depending on its fate. Those are all definitions of lottery that come from the American Heritage Dictionary, and those are pretty good. So now let's see if we can translate that text into something a bit more quantitative and mathematical for our purposes. Well, here's a decision theoretic definition of a lottery. A simple lottery, we're going to write it as L for lottery, of a function of we'll call it x1, p, and x2. It's a probabilistic event characterized by two possible consequences, designated x1 and x2, and their respective probabilities of occurrence, designated by p and 1 minus p. So in our terminology, x1 is one consequence, x2 is another. P is the probability that x1 occurs. So the probability that x2 occurs is simply 1 minus p. Now some more notation. We want to introduce these symbols. These look like greater than and approximately equal to and greater than or equal to, and they're very close to that. But the way we read them in decision theoretic world is we'll read the greater than as is preferred to. We'll read the little approximate sign as is indifferent to, and the greater than or equal to as is either preferred to or indifferent to, respectively. So preferred to, indifferent to, and either, preferred or indifferent to. We need those because there are some fundamental axioms that we need to understand. There's 7 of them in all, and I want to go through those in turn. First of all, the first axiom, the existence of relative preferences. It says for every pair of consequences, x1 and x2, the decision maker will have a preference such that either x1 is indifferent to x2, x1 is preferred to x2, or x2 is preferred to x1. That's axiom 1, the first axiom. The second axiom, transitivity. This should look familiar to you from basic algebra. So if we have any lotteries, L1, L2, and L3, the following conditions hold. That's transitivity. If L1 is indifferent to L2, and L2 is indifferent to L3, then L1 must be indifferent to L3. The second one, if L1 is preferred to L2, and L2 is indifferent to L3, then L1 is preferred to L3. Again, that should look very familiar to you. Third axiom, comparison of simple lotteries. If, for the decision maker, x1 is preferred to x2, then the lottery 1, x1 with probability p1 and x2 is preferred to L2 with probability x1, p2 and x2 if that first probability p1 is greater than the second probability p2. Also, lottery 1, x1, p1, x2 is indifferent to lottery 2, x1, p2, x2, if and only if p1 equals p2. Those should be fairly simple, straightforward for you. Axiom 4, the quantification of preferences. For each possible consequence, x, the decision maker can specify a number. We'll call it pi of x, where pi is actually a probability. It's a number between 0 and 1, such that x is indifferent to some lottery with x star on probability pi of x and x naught. So this pi of x is a good way to measure the preference, essentially. And if you take 3 and 4 together, now we've established a measure of the relative desirability of the various consequences to the decision maker. That's at pi. And that's the value, or indifference probability, and it's called the measure. So pi of x is this indifference probability. The quantification of judgmental uncertainties. This is an interesting one, valuable too. For each possible event, we'll call it E, which may affect the eventual consequences of the decision, the decision maker can specify a number, call it P of E. This is a probability between 0 and 1, such that he or she is indifferent between the lottery, x star, P on E, and x naught, and the situation where she or he receives x star if event E occurs, and x naught if event E does not occur. So it's essentially coming up with our, how do we quantify our uncertainty in the judgment? And that's what the P of E is. The sixth axiom is substitutability. If a decision problem is modified by replacing one consequence or lottery by another consequence or lottery, which the decision maker finds indifferent to the first, then he or she should be indifferent to both the old and the modified decision problem. And then finally, axiom 7, equivalence of conditional and unconditional preferences. Let's let L1 and L2 designate lotteries which are possible only if event E occurs. After it is known whether or not E occurred, the decision maker must have the same preference between L1 and L2 as he had before it was known whether E occurred. So it's indifferent, if you will, to whether or not that probability is conditional or unconditional. Okay, let's give an example now of what we mean by one of these. Suppose that we're asked to choose between two lotteries, call it L sub 1 and L sub 2. And we'll say that L1 yields a reward of $10,000 with certainty. And L2 consists of tossing a fair coin. Heads yields a reward of $30,000, and tails, you don't walk away with anything. This is a pretty good thing to get engaged in. Somebody walks up to you and gives you this deal, I encourage you to take it, because you're going to walk away with probably $10K if you choose that first lottery, and you can't get hurt if you choose a second lottery. So L1 yields an expected reward of $10,000, and L2 yields an expected return of $15,000. Why the 15? Well, it's a fair coin, 50-50 chance. So 0.5 times 30 is 15,000, plus 0.5 times 0 is 0. So the expected value of that L2 is 15,000. So what do you expect? Well, you look at this and you say, wow, I want to go L2. I can walk away. My expected value there is 15K. Depending on the magnitude of the return, and depending on the magnitude of the green in your billfold, that may not be the case. What's been found, in fact, is it isn't. What's been found is that many, if not most people, prefer lottery L1 to L2 because L1 offers the certainty of a large payoff, while L2, there's a substantial likelihood, namely 50%, there's going to be no reward at all. So many of us would take that lottery L1, although the expected return is smaller. Now you remember back in the last lecture, we looked at expected value. One would conclude there that one would take L2 if you're simply basing it on expected value. But now there's this whole notion of risk aversion. Somebody walks up and put $10,000 on the table over here and 30 over there with a coin. How would you react? Well, again, if you have a lot of money, like if your net worth is $1 million, it's probably no big deal. You probably go for the 15K. On the other hand, if you're like me, you probably would. You might want to seriously consider picking up that $10,000 and walking out. So, and in short, most people have this substantial level of risk aversion. Now, how do you capture all that? How do you bring that into the picture in this decision making, trying to minimize this risk out there? Well, let's get now into game theory. See, the reason I wanted to introduce this notion of utilities and utility theory is because all of that, those axioms and so on are fundamental to the game theory that was developed. This is the study of the ways in which strategic interactions among rational players produce outcomes with respect to the preferences or their utilities, going back to utility theory, of those players, none of which might have been intended by any of them. So a lot of interesting things going on in this topic. Some things can happen, unintended consequences can arise if you're not careful in how you do the systems thinking about these things. That can be very surprising, and in retrospect, lead you to the conclusion you really made a bad decision. Who are the founders of game theory? Well, John von Neumann and Oscar Morgenstern. These were gentlemen who lived back in the 50s, 40s. Von Neumann was a key player in the Manhattan Project, was involved in nuclear weapons. Morgenstern was a preeminent mathematician. And they wrote the seminal treatise on the game theory, with the theory of games and economic behavior. And I brought that text along just to say I brought that multi-objective criteria decision analysis text. This is the seminal text on game theory. Again, a fairly voluminous text with over 700 pages in it, most of which is fairly sophisticated mathematics. There have been a lot of people have taken that sense. There are countless journals and journal articles and textbooks and so on written around that. Jacob Bernowski, who you may have heard of, there was a series on it was on PBS here and on BBC called The Ascent of Man, and there had been a book on this. He's a mathematician, and he knew von Neumann well, and I went back through the literature and I pulled out a particularly important exchange between the two I wanted to share with you, give you a sense again of what von Neumann meant when he talked about game theory. We're not talking about football or basketball or chess or checkers even in von Neumann's world, although game theory has been applied to all those venues. But when asked, this conversation between von Neumann and Bernowski, this was von Neumann's response. First of all, Bernowski said, "I naturally said to him, since I'm an enthusiastic chess player, quote, 'You mean the theory of games like chess?' Well, von Neumann's response was, no, he said, 'Chess is not a game. Chess is a well-defined form of computation. You may not be able to work out the answers, but in theory, there must be a solution, a right procedure in any position. Now, real games,' he said, 'are not like that at all. Real life is not like that. Real life consists of bluffing, of little tactics of deception, of asking yourself what the other man's going to think, I mean to do. And that is what games are about in my theory.'" This is a quote from von Neumann. So when he wrote this treatise on game theory, in collaboration with Morgenstern, heavy math in here, he had in mind all these nuances associated with bluffing and trying to deception and tactics that the other person might be using. Fascinating work. So in their world, they got into cooperative games essentially. How might coalitions be formed, and how would those coalitions move forward to come up with optimal strategies and so on. Well, there's another gentleman who came along, introduced this notion of non-cooperative games, and his name was John Nash. Not to be confused here with Russell Crowe, who starred in a movie about John Nash called Beautiful Mind. There's the real John Nash. There have been, this is another point I want to make with you, that this is not a trivial area. There have, in fact, been 8 Nobel Prizes awarded in game theory, and one as recently as last year. Morgenstern and Van Neumann won Nobel Prize. John Nash back in the 90s won his. Lots of very high-powered quality work in this area. Now, there's a classical problem in game theory. It's been called the prisoner's dilemma. That's what most people refer to it today. I want to introduce you to that. And in this particular case, we have 2 people, and we'll call them A and B, and they're arrested by police, in our case, for detonating neo-Luddite explosive devices. The police have insufficient evidence for a conviction, and having separated both prisoners, they visit each one of them to offer the same deal. Now remember, in this example, these prisoners are separated, and they can't communicate with one another. They don't know what kind of deal is being offered or what kind of deal has been taken by their partner. But if one testifies for the prosecution against the other one, and the other remains silent, the betrayer goes free. The one who confesses goes free. And the silent accomplice receives a full 10-year sentence. So the stakes are high here. You can either walk with no time or spend 10 years in prison. If both of them remain silent, both prisoners are sentenced to 1 and only 1 year in jail for a minor charge. So, knowing this going in, you would think the prisoners, if they knew this going in, would say, we can't possibly confess. We'll walk away with only 1 year each, if that's the case. So you think it's a fairly trivial decision for the decision makers, the prisoners going into this. But it gets complicated. If each betrays the other, each receives a 5-year sentence. So now we got something between the two. If you betray your partner, you get 5 years. Both of you get 5 years if you betray. Now each prisoner must make a choice of whether to betray the other or to remain silent. That's essentially the essence of the classical prisoner's dilemma problem. And it sounds simple. It is fairly simple. There's an incredible number of nuances with this. It's been applied, in fact, everything from the kind of problem I've posed here with a couple of folks who've been captured, like the neo-Luddites, to it's actually been applied to strategic nuclear warfare, where we have the primary players being the former Soviet Union and the United States, and countless things between those two in all sorts of venues. So this is an incredibly simple model, but it's incredibly robust. Neither prisoner knows for sure what choice the other prisoner will make. That's sort of the final thing here. So I guess you get the sense of it. You get these 2 people, they've been captured. They're given options whether to confess or not. They know the costs, or we'll call them rewards. In these cases, the rewards are going to be negative of confessing. And those rewards are contingent on what their partner does. So this dilemma poses this question: how should the prisoners act? You go back to those action states we had in the previous lecture on decision theory, where we had a capital A and we had the set of actions A1 through AK. Now we have 2 people making decisions. That's a complication we didn't have in the previous case. and the decision one person makes has can have a profound impact in the outcome, the reward the other person receives based on his or her choice. Lots of interesting nuances here. This is what it looks like. This is the game matrix, and we have prisoner A decision along the rows and prisoner B's decision along the columns. The two options in each case are confess or don't confess. If they both confess, they both serve 1 year in prison. If they both don't confess, if they continue to cooperate with each other and do not confess, then they serve 1 year in prison. If they both confess, then the service is a little heavier, 5 years in prison for both of them. If prison A confesses, but prisoner B does not confess, and guess what? Prisoner B goes to prison for 20 years, and prisoner A goes free. I think I might have misspoke in the previous slide. I said it was 10 years, so this is a correction. 20-year sentence if prisoner B does not confess and prisoner A does. And conversely, if prisoner A decides to not confess and prisoner B confesses, then A serves 20 years and B goes free. Big stakes here. So what do you do if you're prisoner A or prisoner B? This is what the reward matrix looks like. So the first entry is prisoner A's reward, and the second is prisoner B's reward. So if they both continue to cooperate with one another, they don't confess, they both receive a year in prison. That's hence the -1. If they both confess, they both get 5 years in prison, -5s. If A does not confess, then B does. A goes to jail for 20 years. That's the -20. If A confesses and B does not, B goes to jail for 20 years, and A goes free. So that's the reward matrix. So now let's get to another definition here. It's an equilibrium point. A choice of a strategy by each player we'll call an equilibrium point if neither player can benefit from a unilateral change in strategy. And what does that mean? The point -5 I'll claim as an equilibrium point, and here's why. If either player changes his or her strategy, then his or her reward decreases from -5 to -20. Remember, you're sitting off in that lower right-hand corner of that matrix. And you can either go to the right or up. To the left or up. If you go up, you're going to, player B, I believe it is, gets a 20-year sentence. If you go the other direction, player A gets a 20-year sentence. So it behooves you, if you're in that state, -5, to stay there. And that is that equilibrium point. If both players are better, you notice that are better off at that state -1. But -1 is not an equilibrium point. Why is that? Well, if you're currently at that state -1, then each player can indeed increase their reward by changing their strategy from don't confess to confess. That way they go from -1 to 0. So you can't stay in -1. That's a state of disequilibrium. But you can stay in -5, a state of equilibrium. Because each player can benefit by double-crossing his or her partner. That's the bottom. That's the upshoot of this whole thing. Now let's define some more notation. NC is a non-cooperative action. C is cooperative. P is the punishment for not cooperating. S is the payoff to the person who's double-crossed. R is a reward for cooperating, and both players cooperate. And T is a temptation to double-cross your partner. So with that notation, what does that, going back to our example, what does that mean? Well, this is the way it sets up in the prisoner dilemma reward matrix. We have the tuple P, P in the upper left, T, S in the upper right, ST in the lower left, and RR in the lower right. And to be a true prisoner's dilemma. We have to have T, the temptation, greater than R, greater than P, greater than S. Well, in our example, P is -5. It's the punishment for not cooperating. S is -20. That's the payoff to the person who's double-crossed. R is -1. That's the reward for cooperating if both players cooperate. And 0 is the temptation for double-crossing your partner. In other words, you go free, 0 years in prison. So because 0 is greater than -1, greater than -5, greater than -20, our example does indeed qualify as a true prisoner's dilemma, based on the condition I just showed in the previous slide. So that's the classical problem in game theory. There are many textbooks, and there are countless, I hate that word countless, but I used it anyway, lots and lots of articles written on that topic. And it's been applied to many different applications, economics and biology, computer science, social science, and, as I mentioned earlier, strategic nuclear warfare. It's a surprisingly robust problem, and all the little many nuances around it have taken people in all sorts of interesting directions. So lots of insights can be gained from studying that one little example, one little problem. Now, I want to share with you a word from again, the theory of games and economic behavior. This is a direct quote of a text, and it's really important for us here in this class. This all harkens back to something that Professor Hochstetler cautioned us about early on, about people are not machines. True, that's true. And I even elaborated on that. This is not all systems behave mechanistically, so it's beyond just people are not machines. She's absolutely right there. But at the other end of the spectrum, in all fairness to people who have developed and successfully applied these decision theoretic and game theoretic and utility theoretic concepts, they do in fact add value. People have learned from these things. So this is a quote out of the text from John von Neumann. And I quote, "It is not that there exists any fundamental reason why mathematics should not be used in economics and social theory writ large. The argument's often heard that because of the human element, of the psychological factors, etc., or because there is allegedly no measurement of important factors, mathematics will find no application. That can be dismissed as utterly mistaken." Those are von Neumann's words. "Almost all of these objections have been made, or might be made, many centuries ago in fields where mathematics is now the chief instrument of analysis." And this passage goes on. "This might have been is meant in the following sense. Let us try to imagine ourselves in the period which preceded the mathematical or almost mathematical phase of the development of physics, that is the 16th century, or in chemistry and biology, that is the 18th century. Taking for granted the skeptical attitude of those who object to mathematical economics in principle, the outlook in the physical and biological science at these early periods can hardly be better off than in economics, mutatis mutandis at present." So, quid for pro. This is just a way to say that economics and then social theory in general, the application of mathematics to those disciplines is a lot like the application of mathematics was to physics and chemistry and biology hundreds of years ago. But it does have its place. And with all these Nobel Prizes I've been telling you about, those, by and large, are awarded to people because they have demonstrated that game theory does, in fact, all the richness of the mathematics associated with it, does, in fact, to contribute to enhancing the quality of life and the human welfare in our world. So there's evidence accumulating and piling up right now that, once again, mathematics is going to step up and help us with our understanding of these phenomenology. Okay, that essentially wraps Module 2 for the course. We've talked again about System of Systems Analysis Toolset. We've talked about intelligent agents, about risk analysis. We've gotten into decision theory, decision analysis, a bit about utility theory and game theory. Tried to highlight the importance of all the nuances associated with each of these things, where you can get into multi-criteria, multiple decision makers, and so on. And I'll encourage you to please be cognizant of all those complicating factors, and engage in systems thinking when you're approaching these problems. So we're going to have an exam coming up. I'm going to provide that exam on Friday. I believe that's going to be May 4. I'm going to deliver that exam to you via your New Mexico State internet account on or before 5 p.m. and it will be due 7 days later, the following Friday. I'll specify that in the email that I send out, on or before 5 p.m. So with that, let's get off. Again, I think I mentioned some of these things in lecture 20, but some I didn't. So let me go over these again. The content and schedule for the remainder of this semester. Exam 2 will cover the modeling and analysis tools to which you have been introduced. That's going to be distributed on Friday, April 4, no later than 5 p.m. And that'll be due to me on Friday, April 11th, no later than 5 p.m. Once again, you have 7 days. Now the class project. That goes beyond, it's our third module, essentially. It's going to build on the materials you've learned in the first 2 modules of the class. It's going to require you to engage in systems thinking. And it's going to be due no later than Friday, May the 2nd. And late materials will not be accepted. That's because the semester ends. I have to grade those and get the grades in. Now, in preparation for exam, these are the things we covered. Modeling and analysis of when we use System of Systems, SOSAT, we used intelligent agents, risk analysis, decision analysis, game theory. We had utility theory in there. But if you'll just focus your attention on these 5, that'll be sufficient. Time management. It was clear to me that the few of the students in the class had not spent the time on exam 1 that would have allowed them to do a better job. Let's just say it that way. When I looked at those exams, most of the students spent several hours, but some of the students spent just a few minutes, and that just won't get it. You got to spend more time on exam 2 than that. So I'm encouraging you now to plan ahead. Reserve at least 5 hours this next week to spend in developing your responses to exam 2, and that's during the 7-day period of April 4 through April 11. Allocate 5 hours at least to spending on that exam. Now, once again, with time management, let's talk about Module 3. Most of the work on this class project will be done during the period April 14 through May 2nd. That's about a 3-week period. And I'm encouraging you to plan to spend at least 5 hours per week on average working on that project during that 3-week period. Any material you submit after May 2 will not be accepted. What is the class project? Well, the objective is going to be the management of the Neo-Luddites' radical behavior. The approach is going to be using social movement theory, reverse reductionism, and a federation of the models or the analysis tools you've seen. Now, by federation, I don't mean you have to literally have these software packages coupled. In fact, you can't even get access to some of these software packages. So I'm looking for sort of the analytic coupling, if you will. If you choose to use intelligent agents, which, by the way, you do have access to, if Shannon provided that for you. But if you choose to use that in concert with decision theory, how are those analytic tools talking to each other? I want to know that conceptually, and I want you to be able to demonstrate it to me in your analysis you've done. Doesn't mean running an necessarily decision theoretic model or a game theoretic, an intelligent agent model, and having the software talk to it. I don't mean that at all, but it does mean having the analysis be synergistic somehow. The expected results is a portfolio of policy options that help solve the problems arising from the neo-Luddite aversion to technological progress. Now, in the first exam, when I asked for people to address the neo-Luddite problem, some of the students went back to the original definition of, well, all we're doing is we want to maximize probability of detection here. Well, I hope you understand with this, we're well beyond that. This is well beyond just maximizing probability of detection of a neo-Luddite device. Now we're into the larger context, a bigger system. Draw the box a little larger now. What we want to do is address problems arising from their aversion to technological progress. It can, in fact, include detection probabilities of the devices, but it's far, far richer than just that. A constraint is the modeling and analysis tools that you use should include SOSAT. And I'll say again, you cannot get access to SOSAT, so obviously you cannot run it. Nevertheless, the concepts there, setting up the input files, interpreting the output files, you can in fact talk to, and that's a legitimate tool set for you to use on the class project. Intelligent agents, there's one that you can in fact run because of the software that was provided to you. Risk analysis, decision analysis, and game theory. So those are the big five. I want you to be able to pick and choose at least two from the list. I'm going to throw another one up here now, and that's systems dynamics. That's what I'm going to get into in the next set of lectures. That's not required to use systems dynamics. We can use any two or more of the other five above it, but it is strongly encouraged, and that's because you'll see when you get into systems dynamics that it's sort of a natural segue that comes out of systemic characterization of a system, because you'll build these influence diagrams which can lead directly to characterizing quantitatively the interaction among state variables or domain elements vis-a-vis the arrow connecting the two, the dynamics, by putting differential equations on those dynamics. And I'm going to show you that later. So I do strongly encourage you to seriously consider using system dynamics as one of the two or more, but I'm not requiring it. But I am requiring two of those six. You can bring in other tools that you have in your tool chest if you choose. That's fine. I encourage you to do that. There are other things that you're familiar with. But those you cannot count as part of the two. You've got to pick two from this list of six. The deliverables for the class project are first a report in a Word file that articulates the results of the project, a presentation in PowerPoint that provides a briefing of the project, and we want an outline of the report. Here it is. I'm going to tell you the targeted page length that does not include the figures, and this is all the pages except for the cover. I want everything to be in 12-point font and a single-spaced. And I mentioned this before. I've had other students in other classes try to game this, so to speak, by introducing 18-point font and triple space. Let's not go there. Let's use 12-point font and single space. There should be a cover page that consists of the title and the class project, you, the author, and the date. Class title, of course, is Large-Scale Systems. The second section, the report, is the executive summary. I'm thinking in terms of a half page. The third section is the introduction. That's about a page in length. It should show the motivation, the background, and introducing the problem. The fourth is the approach, 2 pages. And the fifth is the results, 4 pages. And we have a sixth, which is a commentary, consisting of a summary, conclusions, and recommendations, 2 pages. And you're welcome to use appendices as you please, and Number of pages there is arbitrary, as many as you wish. I encourage you to use figures and graphics throughout, but they don't count as part of your page count. That's got to be text. 12-point font, single-spaced. Now the presentation should have a title page, one slide, an overview of the purpose and results, another slide, what's the motivation or the background for this work, one slide. Now I don't mean in motivation and background, just simply tell me it was a class project in ie537. I want you to think in terms of the decision maker in the Neo-Luddite world and create the background and the motivation for solving that problem as that decision maker. What's the approach that you used in the project, one slide. What are the results, 4 slides. And then a commentary. Summary and conclusions, one slide. Recommendation, one slide. A word about the recommendations. What you're likely to find when you finish this project is you're far from finished. You're likely to find that there's a lot of other stuff that needs to be done if you're really going to properly address and resolve this Neo-Luddite problem. And so the recommendations should focus on that. So what's next in this project? What's the next logical set of things for the modeler or analyst or the decision maker to engage in? Let's see. I think I mentioned last time also, or lecture 20, this notion of an elevator speech. I want to underscore that again. It's not at all unusual for a person, an analyst, a modeler, to approach his customer, his or her customer, and want to present the results, but that customer doesn't have the time to spend with them. So there you are. I set this example up for you. You're waiting in this person's office. They're an hour late. They come in, and although you had an hour originally scheduled and it was on their calendar, now they don't have the hour. So they say, okay, come with me. I got to go to a meeting. So you go with the person. And you quickly arrive at the elevator. You have a 3-floor ride from that person's office down to the next level where that person's going to be having another meeting. You've got 3 floors to make your point. So you need an elevator speech essentially, and that elevator speech essentially should be captured in your executive summary of your report. And here in the overview of purpose and background and motivation and your results, you should think of a way to somehow within 3 floors articulate to this person the importance of what you've done and the results, and how those results might be used by him or her to make the decisions that he's faced with. And with the presentations, I really strongly encourage you to make very liberal use of graphics throughout these slides. Minimize text here. Now, the presentation and the report are very closely coupled, very synergistic. I would be surprised if you'll have a lot of graphics and pictures in your PowerPoint file, and that's fine. Very few words. I'll be surprised if there are none of those graphics that appear in the PowerPoint file that do not appear in the Word file. I'd be surprised if that doesn't happen. So these things are very synergistic. They play very closely together. They should be telling the same story, but they're just different presentation media. Okay, now let's talk about the project, a way to sort of jumpstart it, if you will. Now realize and recognize that you're going to be preparing for exam 2, as you should. But I want you to start thinking ahead about your project now. So I'm going to give you a couple of weeks jumpstart, if you will, on the project. And to the extent that you can begin to think about projects and what you might be doing, keep this in the back of your mind as you're studying for exam 2. Going to be basing it on this social movement theory, the influence diagram, the systemic characterization that was given to you on Module 1. I'm going to give you a little bit more meat, if you will, on that systemic characterization here today. So that gives rise to a framework for the analysis, and I showed you a glimpse at that at the last lecture, lecture 21, where we have policy categories and quality of life categories. Now, if we are going to have any hope of influencing this neo-Luddite social movement to achieve our goals, we have to first of all understand the notion of social movement and the effects of different policy options. So these are the various players. I show the cartoon of the neo-Luddites and the bystanders and all the decision makers associated with this problem. You got to understand the how all these players play together, essentially, in this problem that's out there. Typical dimensions of quality of life. We have human health, human rights, economic well-being, environmental quality, cultural heritage preservation, and availability of services. Finally, confidence in government. These are factors that will influence the social movement. And again, I mentioned this in Lecture 21. Let me highlight it again. These 7 different dimensions of quality of life are ones that you should seriously consider and explore in thinking about your objective function, if you will. And you can imagine there can be a variety of different measures of each of these 7 categories. You can have more than one measure per category. So now you've got to come up with a way to combine all those. You got to define what those measures are, and then you have to combine them in some meaningful fashion. Not a trivial exercise. Policy categories, again, these are ones I mentioned in the previous lecture, but I want to highlight them again. Regulations, fiscal incentives, information, education, outreach, technology development and deployment, intergovernmental relations, and enforcement. Now, these are your controls. These are actions, if you will, that you can effect to make changes somehow to this social engine characterized by social movement theory to influence those quality of life categories out there. Now, let's just say a word about these policy categories and about the quality of life dimensions. These were not just randomly made up. These came out of about 10 years of experience when we ran over 90 different instances of the vital issues process where we asked stakeholders around the world to identify those quality of life categories, and similarly to identify these different policy categories. So I'll reflect back on your introduction to linear algebra. You probably got into things like vector spaces and bases and so on. So I think of these 7 different dimensions of quality of life and these 6 different dimensions of policy categories. What I think about is something like a vector space. My claim to you is that with these 6 different dimensions of policy, you have the equivalent, if you will, of a vector space that spans a space of policy options. You don't want to lie along any one of those vectors, dimensions. It's going to be a multidimensional solutions, so you have to look for combinations of these 6 different categories. Similarly, on quality of life, 7 different dimensions there. You can think of that as forming the basis for a 7-dimensional vector space for quality of life. It's even more complicated because there are measures for each one. But I want to stress again that you don't want to focus on any one of those dimensions, those 7 dimensions. Somehow you got to think holistically about all 7 of those when you're creating a policy portfolio out of these 6 different dimensions that somehow map into the 7 different category dimensions of quality of life. Systems thinking is going to be paramount on this. All right, social movement theory. You recall we had these 3 different domain elements, and the assumption going in here is that the social movement theory is a reasonable avenue to help us understand this neo-Luddism, radicalism, if you will, their violent acts. So we pick up on each of those dimensions. We have, first of all, the framing process, and secondly, the opportunities and constraints, and third, the resource mobilization. Let's focus on the framing first. In the framing process, that is all about diagnosing the problems and the need for redress of the problems. It's also about providing a rationale to motivate support and some collective action. It comes up with solutions, strategies, and tactics that ameliorate the injustice. in picking those apart one at a time, diagnosing the problem from the neo-Luddite standpoint. They see all these as problems that they're having: rising unemployment, stagnant economic development, soaring debt, housing shortages, dwindling social and welfare programs, state repression of the citizenry, and then spread of other values and practices, and probably a host of other things. But these are meant to be examples, if you will, of what the neo-Luddites see as the problem associated with this evil technological progress that they're countering. Solutions that they offer to ameliorate the injustice is, first of all, neo-Luddism is the solution. Let's create a society that's governed by neo-Luddite law, and let's control the state as a means to that end. The rationale to motivate the support, there are several of these. One is the personal salience of the frame. So if they're talking to other neo-Luddites, if they're talking to bystanders, they need to bring home, they believe, the neo-Luddites need to bring home how personal this issue of unemployment and housing shortages is to the person. Empirical credibility means they can clearly, neo-Luddites can clearly show that there are indeed unemployment data and housing shortage data that are really credible. They're not fictitious. The consistency of the frame, showing that in fact all of these different ills are due to the same social problem, this technological progress. The cultural consistency has to do with the neo-Luddites largely claiming that in their culture they're all about anti-social progress, and everything they argue has to be consistent with that cultural imperative. The reputation of the framing individual, well, the person making the argument, the neo-Luddite, has to be well respected and well recognized in the community. All these things taken together create this notion that we'll call resonance. And when we do that, this is one, it's not unique, but it's one systemic characterization of the framing process. I'm not going to go through this in detail. It will be available for you in the PowerPoint. It's going to be on Lecture 2. The only one of the fundamental differences between this and the influence diagram that you created vis-a-vis your systemic characterization is I've gone the next step and I've put a plus or a minus on each one of these arrows indicating the direction of influence. So, for example, a government ineffectiveness and corruption leads to with a plus sign there, and unemployment at the top there means it increases in unemployment. And just below that you see economic development. Well, if we have government ineffectiveness and corruption, it tends to decrease economic development, hence the minus sign. So that's all that's intended by those pluses and minuses. Okay, very quickly, the next dimension is that of opportunities and constraints. Here we're talking about perception of opportunities or the threats, access, both formal and informal, to political institutions and decision-making, and then finally the rationale for the decision-making, that it's both maximizing opportunities and minimizing the adversity. This is not unlike the kind of thing we saw with, for example, the case where we had Edsel Ludd wanting to buy the etching. What he was trying to do is minimize cost and maximize the aesthetic value. So he was faced with just this dilemma. Well, in opportunity constraints, this is what it looks like. Again, this is not unique, but this is one representation of the systemic characterization of opportunity constraints vis-a-vis an influence diagram, once again with the pluses and minuses. The only thing new on this graphic that I don't believe we saw in the last one, you see these double hash marks on a couple of the arcs. What that means is there's a temporal delay. So when we have a political, social, cultural, and economic problem, there is somewhat of a temporal delay before we perceive the opportunities or perceive the threats. That's all that's meant by that. Social movement theory dimensions, again, the last one is resource mobilization, and it involves the mobilization media, There are social movement organizations. There are also informal social networks. There's a public perception of the value, both positive and negative, of the state and the value of the social movement organization. Come up with a systemic characterization influence diagram associated with that. You can see, again, not unique, but one representation. A few more time delays in this one as well. So that's a start for you for the systemic characterization, the modeling, if you will. Now we've got to somehow also recognize that those things couple, as shown here. And this is a start at the coupling that's shown in the red. The red arrows show the connections, if you will, between and among those domain elements: resource mobilization, opportunities and constraints, and the framing process. Again, this is not unique, but it's at least a start at what I'm calling here now social movement theory kernel. So this all social movement theory, if this were indeed reasonably accurate, all social movement theory could in fact be represented by this sort of framework for future analysis. It's largely topological at this point. There's no mathematical expressions or anything with it, but there is a way, a path forward to take this into the to the mathematical world. So once again, the framework I'm suggesting for your consideration for Module 3 is begin with that social movement theory kernel. That's the socioeconomic engine. We have the non-anthropogenically induced stresses. I talked about those in the last lecture. We have the anthropogenically induced stresses from the neo-Luddites themselves. We have a set of policy categories from which to pick and choose, and we have a set of quality of life categories, again, for forming our objective function in life. So it's all about bringing all this together. In our class project, what we want to do is just this. We want to come up with a policy portfolio, the things on the left, ranging from regulations through fiscal incentives and so on through enforcement, that somehow optimizes or maximizes the net effect on quality of life, things ranging from human health through human rights through availability of services. That's our challenge. And hopefully you can see how all of this connects back into Module 2 and Module 1. So that's it for this lecture. I wish you well and luck on the and Godspeed on the Module 2 exam.